Good morning everybody and welcome to another technical video at Dygma Labs with your host Matt Venn. Welcome. Today I'm going to be talking about the electronics and the PCBs of the split raise keyboard. So let's start off with the beginning. You're going to take the Hubble and plug that into your computer, and then that gets split with two cables to the left and the right hand side. The reason that we did that is because we want you to be able to use either the left or the right side on its own, and that means we can't have the USB chip in one side or the other. We would need either two separate USB keyboards or the USB chip split and then split the wires down into the keyboards. So the stuff in here is the stuff that deals with the USB stuff and talking to the PC, and the stuff in here deals with reading the key presses and controlling the LEDs. So let's have a look at what's inside. Inside the Hubble, we've got this circuit board here, and this has got a USB-C socket here to get the data, the USB data, and the power to control the whole keyboard. The chip on the back is what does all the work, so that we load the firmware onto that, and that does all the coordination. It talks to the computer via USB, and it talks to the keyboard sides with a protocol called I2C, and that information comes out of the sockets here and here. We've also got an LED on the front to shine out of this hole here, and we've got a reset button here in case stuff goes wrong or to help with uploading new firmware. So what happens after the data and the power comes out of here? It comes down the two USB-C cables and into the USB-C sockets in the back of the keyboards. Like I said earlier, you can have one or the other or both. Inside the two sides we've got these two extra circuit boards. Actually there's four, there should be another little one on the other side, but I didn't bring that with me. So the power and the I2C communication comes down here. We have a little soft start circuit here so that if you plug it all into the computer together, we don't get a big power supply jolt. And then the main computer on each side is this microchip here, which is an 8-bit microcontroller from Atmel, and its job is to read all the keys as quickly as it can and to control the LEDs. So if the keys are going to all be read, the Hubble sends the information down the I2C. These little chips here receive that information, they send the data to tell the LEDs to go red to the LED driver here, and that's the bit that actually controls the LEDs. So for every key we've got one of these cool sockets. So these are the hot plug sockets that let you change your keys, so you can pull these in and out. Once the key is latched into the top plate, you need a little tool to help you unclip it, but this is what does the electrical connection. And then underneath we have a reverse mounted RGB LED. So inside each one of these little white boxes is a red, a green and a blue LED, and then we have a diode here for each key. That's to do with scanning the matrix of keys together, because instead of reading each key individually, we're scanning in a kind of column and row matrix, and the diodes are an important part of that. The only other part of the PCB that I want to explain is that we need to have this little plug here. This is a little join and nice little action there. So we have this extra little circuit board here which has got its own two LEDs and its own set of sockets for the low profile switches, and those are these ones here. And it's a bit annoying, but because the low profile switches are thinner, we have to have the PCB at a different level. So the low profile PCB has to be just a little bit higher than the normal PCB to get it all fit properly. So we have to have a separate PCB, and then this is plugged in with this flexible wire and clipped together like that. So that's pretty much the whole product in terms of its PCBs and the overall functionality. Thanks for watching the video.
If you're interested to learn more about the Raise keyboard, you can click the subscribe button. Or if you're interested to purchase one of these beauties, you can head over to our website at dygma.com.